So what we're going to do is we're going to take and start making connections back to how we dealt with that mixed number in the previous problem, and look at it in terms of rational expressions where we have variables in the numerator and the denominator. And so it says to find the quotient by factoring the numerator. Just to remind us on how to factor this, this would be 2 times -7, which is -14. And that's my product side. My sum side is +5. What number is multiplied to -14, but sum to +5, that's -2 times 7. So -2 plus 7 equals +5. And if I'm factoring the numerator, 2x times x gets me to 2x squared. What times 2 equals -2? 2 times -1. Put the +7 over here, all divided by x minus 1. I'm going to add the parentheses just so you can see that it must match exactly, and the grouping symbols have to keep it. And so this expression divided by its equivalent equals a 1. And so my answer is 2x plus 7. This is nice. There's no remainder. We were able to factor it. Makes life easy. But if we look at the exact same or very similar expression, they're different. This says -7. The new one says -5. And so what that tells me is not only one, there's a little bit of difference, but there's also it's not going to divide evenly like we just saw. And so we've got to start thinking about what we can do. Well, what we can do is we can start to compare the process from what we knew worked, which was 2x squared plus 5x minus 7, versus what we have presently. And so what we can do, there's this neat trick, is that there's this thing called the additive identity, which we should know is 0. So if I were to add and subtract the same number, or subtract and add the same number, it would keep everything balanced. And so that's exactly what I'm going to do. I'm going to take the 2x squared plus 5x minus 5, and I'm going to add in a -2 plus 2. Well, this part is equal to 0. And so it leaves the expression unchanged. And then what I do is I just kind of group it, and I'll see that this is 2x squared plus 5x minus 7 over x minus 1. And then this is sort of out there as a plus 2. And then if I go back to my fractional operations example from the previous problem, what I can do is actually pull these apart as long as I keep the denominator. And so knowing your fractional operations becomes really, really important. But this is 2x squared plus 5x minus 7 all over x minus 1. And on the other side, what I'll do is I'll add the 2 here and divide by x minus 1. So as long as I have the denominators, I can add the numerators, keep the denominators. And from the work we just did, we knew this is 2x plus 7. The remainder gets expressed by 2 over x minus 1. Okay. Now you might be thinking that this is a little bit of crazy math. It's actually based very solidly in your fundamental math, which is this additive identity. But if you're unsure, I suggest that you always use long division to prove it. So here we go. 2x squared plus 5x minus 5 divided by x minus 1. What do I multiply x by to get 2x? Well, that's 2x. 2x squared minus 2x. Subtract. So this becomes a 0. This is really 7x minus 5. What do I multiply x by to get 7x? Positive 7. these two expressions now match exactly. So the hope is that my remainder is 2. Let's see what happens. 7 times x is 7x. 7 times negative 1 is negative 7. When I subtract these, I now get a remainder of 2. And so I would have written this in previous examples like that, and they match. Okay? So now you've been validated in your expression. But the question really becomes, can I use reverse tabular method? And so reverse tabular method will work, but you have to start in this top left-hand corner, which was what we suggested all along. So I actually do not need that extra box. Got a little excited showing you guys this. Got a little overzealous. Okay. Because I have a quadratic. So I know that this is 2x squared. I know my divisor is x minus 1. And so what did I multiply x by to get 2x squared, but 2x? 2x, negative 2x. I need to have a positive 5, so I know that this was positive 7x. And so positive 7 times negative 1 is negative 7. But I'm supposed to have a negative 5. So what was my remainder? Because this is, it's kind of weird, but it's essentially negative 5 minus, taking away that, the negative 7 leaves me with a positive 2, which is my remainder. So you can use reverse tabular method. I prefer to use long division just because it's direct. But you can use this. You must start in the top left-hand corner of it. And then you really have to make sure that you subtract the two numbers that you get, one being the one from the original expression, one being the one in the box, to get your remainder. Okay, I'd like to do one more example with you guys, just to make sure we're feeling solid with this. And to review a few things. So here we have find the quotient by factoring the numerator. What I notice is that this is a difference of cubes. And I know the difference of cubes has a special form. A minus b, a squared plus ab plus b squared is equal to a cubed minus b cubed. We were supposed to memorize that early in the year, so we'll act like this is our review. And so I can rewrite this as x. I know that 27 is really 3 cubed, so this would be x minus 3, following the pattern. And so I get x squared plus 3x plus 9, all divided by x minus 3. Well, that makes a 1, having the same exact expression in parentheses in the numerator and the denominator. So my final answer is x squared plus 3x plus 9. So this worked out. Remainder 0. You can always check your work with long division. But really what we're here is to kind of make a comparison between what we do know and what's new. And what's new is this will not work out nicely for you guys. And so what we need to do is we need to make the connection between what worked nicely and what doesn't. And so what I notice is that I could have factored this if this were minus 27. So kind of keep that in mind as I'm going through this. This is the difference of perfect cubes. If this is a minus 27, it's a minus 24. So what I have to do is I have to take the x cubed minus 24. I'm going to add negative 3, but I'm also going to add plus 3. And so this part of the expression is that 0 that we're looking for, all over x minus 3. So I rewrite this, x cubed minus 27 plus 3 all over x minus 3. And it's really important that you understand that this maintains equality because I'm really adding a 0. And adding a 0 doesn't change the expression. And then the x cubed minus 27 divided by x minus 3 can sort of be split apart from the 3 as long as I maintain addition or subtraction and I keep my denominator. And so the left-hand side, we just did all that work, so we might as well use it. X squared plus 3x plus 9. On the right-hand side, that tends to be our remainder. And so that would be how we could do the remainder. If you want to see it done with reverse tabular method, we take our divisor, and then again, you have to start in the top left-hand box, but that's x cubed okay. X cubed was, what did I multiply x by to get x cubed? X squared, that's negative 3x squared. Originally there was no x squared, so that's positive 3x squared. What did I multiply that by? It was 3x, so that's a negative 9x plus 9x. So I need a plus 9 times negative 3 is negative 27. But I wanted a minus 24. So what I have to do is negative 24 minus negative 27, which is a 3. And this ends up being my remainder. So you can use all the styles of math that you've been working with. Please pause, summarize, write down any of the vocabulary if you need to go rewind the video. Thank you for your time.